where two neurons come close together but do not touch one another. A minuscule gap, called the synaptic cleft, separates the synaptic terminal of the first or presynaptic neuron from the dendrite or cell body of the second or postsynaptic neuron. The arrival of an action potential at the synaptic terminal causes the synaptic terminal to become positively charged and release neurotransmitters into the synaptic cleft. The neurotransmitters diffuse rapidly across the synaptic cleft and bind to receptors in the membrane of the dendrites or cell body of the postsynaptic cell. Each type of receptor in the postsynaptic membrane binds to a specific type of neurotransmitter, and after binding to a neurotransmitter, the receptor causes specific types of ion channels in the postsynaptic membrane to open. As ion channels are opened, ions flow across the cell membrane of the postsynaptic neuron along their concentration gradients. This flow of ions into the postsynaptic neuron causes a postsynaptic potential in the dendrites or cell body. Depending on the channels opened and the ions that flow in, synaptic potentials can be either excitatory, making a neuron less negative inside and more likely to fire an action potential, or inhibitory, making it more negative and less likely to fire. An excitatory postsynaptic potential is called an EPSP. An inhibitory postsynaptic potential is called an IPSP. A synapse that produces EPSPs in the postsynaptic cell is called an excitatory synapse, while a synapse producing IPSPs is an inhibitory synapse. Postsynaptic potentials cannot travel far in a neuron. After a few millimeters at most, the ions leak back across the membrane and the signal is lost. However, postsynaptic potentials travel far enough to reach the cell body, where they determine whether or not an action potential will be produced.